Good morning, good afternoon, and good evening, ladies and gentlemen. Thank you very much for joining us at today's webinar organized by Agora Industry and the Next Group. I'm Kwang Yam, Senior Associate South Korea at Agora Energiewende. I'll be moderating the first part of today's webinar. With Russia's invasion of Ukraine now in its fifth year, and the US strikes on Iran that began earlier this year, the energy crisis shows no signs of abating. Meanwhile, climate protection has already disappeared from the news headlines, and countries everywhere are prioritizing short-term measures to stabilize energy prices. Given the fact that geopolitical conflicts have triggered the fossil fuel supply crisis, some argue that at this moment might in fact be the best turning point to break free from the fossil dependency and also drive on energy transition centered on renewables. More specifically, they point out that rather than using taxpayers' money to suppress soaring fossil fuel prices and the electricity prices, investing those funds in the rollout of renewables and electrification technologies would lay the foundations for a more sustainable energy economy by reducing long-term dependence on the fossil fuels. In this context, today we want to explore decarbonization strategies for the chemical industry. The chemical industry is uniquely intertwined with our daily lives, more so than any other manufacturing sector. From plastic bags to computers, smartphones, and even eyeglasses and artificial organs, humanity today is inseparable from the product of the chemical industry. At the same time, the chemical industry, alongside the steel and cement sectors, is known to be one of the largest greenhouse gas emitters, whilst also being one of the most challenging sectors to decarbonize. Today's webinar is dedicated to exploring strategies for decarbonizing the chemical industry. We have two presentations lined up. The first presentation will be delivered by Mr. Leonardo Collina, working for Energy Technology Policy at the International Energy Agency. He will be delivered the presentation on global status quo, why petrochemical electrification matters. Then this will be followed by a presentation by Ms. Sugang Kim, Senior Researcher at the Next Group, South Korea's leading think tank. She delivers on the presentation on the petrochemical electrification technologies and potential in South Korea. Following the two presentations, the panel discussion will take place with Paul Munich from Agora Industry and our two presenters. This panel discussion will be moderated by my colleague Kajol from Agora Industry. If you have any questions regarding the presentations or panel discussion, please feel free to submit them via the Q&A box at any time. For questions requiring a simple fact check, colleagues from Agora Industry or the Next Group will respond in real time. But should any matter require an in-depth discussion with the speakers, Kajol, who is moderating the panel discussion, will put the questions directly to the panelists. So right then, let's hand the microphone to our first presenter, Mr. Leonardo Collin. Leonardo, the floor is yours.
Thank you very much, and good morning. I'm Leonardo Collina, indeed. I'm an analyst in the technology division here at the International Energy Agency. I'm gonna share my screen to share the presentation. During the presentation, I'm gonna first touch quickly on some key trends on the chemical industry that happened in the chemical industry in the last few years. And then I'm gonna try to deep dive a bit in the topic of electrification. Industry trends first. And so global energy demand for the chemical industry grew at an average 2.5% year on year for the last 2 decades. This was faster than overall industry and of most of other industrial sectors, with the exception of non-ferrous metals among other energy-intensive industries. This growth, as for many other industrial sectors, has been led in particular by the large expansion of the Chinese economy. China, in fact, is accounted for only 20% of chemical energy demand in 2005, while its share is more than double today at 42%. On the other hand, advanced economies made 50% of chemicals demand in 2005 and only 30% today. Although the picture in advanced economies is somewhat asymmetric, as the demand in North America grew in absolute terms, driven by the availability of cheap natural gas and natural gas liquids brought by the shale revolution. Demand in Europe has been roughly constant for 2 decades, when it suddenly dropped around 2022 due to the energy crisis and other market dynamics. The chemical industry is also the only energy-intensive industry that's projected to keep growing at sustained pace to 2035 in our stated policy scenario, although slightly lower than it's done in the past. It's impossible not to talk about oil when looking at the energy demand for chemicals, as it makes almost half of its demand, particularly as a feedstock to produce the building blocks of plastic products. Coal and gas play also an important role to provide heat to certain industrial processes, but also as a feedstock to a different set of products, such as ammonia and methanol. Electricity makes only around 10% of chemical energy demand when including feedstock, and its share has been roughly constant over the past 2 decades globally. But I'm gonna talk a bit more about that later on in the presentation. Oil demand peak around 2030 in the stated policy scenario, before starting a slow decline. The electrification of road transport is one of the main drivers of oil peak in the steppes. And another important driver of slowdown in oil demand is a shifting away from oil in the power sector, particularly in Middle East. On the growth side, demand for aviation and shipping is set to increase strongly in the next decade in the steppes. But the main driver of oil demand growth is the industrial sector, and more specifically from petrochemical feedstock. We estimate that petrochemical feedstock accounted for 9% of oil demand in 2005, a share that grew up to 13% today, and is kept growing. Is set to keep growing to 16% by 2035 in the steppes. This growth that I've just described has been particularly driven again by China, also in terms of growth in feedstock demand. And China, indeed, in the last 5 years, has added new olefins capacity that is roughly equivalent to the existing capacity in Europe, Japan, and Korea combined. And we expect also China to keep adding as much again before the end of the decade. Sorry. This fleet is a combination of world-scale naphtha crackers closely integrated to new refineries, as well as steam crackers based on imported NGL feedstocks and propane dehydrogenation plants. This Chinese wave of additions follows a previous one in North America, which was focused on monetizing local ethane supply made available by the increase in shale gas extraction. Moreover, China has also been at the forefront of the development of a new industry, which is often referred to as coal to chemicals. Certain Chinese provinces have been able to exploit local cheap coal resources to reduce their dependency on oil imports. These facilities convert coal to methanol and then methanol to olefins, as an alternative to traditional steam crackers, but they come with significantly higher greenhouse gas emissions. The increase in propylene production from propane dehydrogenation facilities is likely to have impacted heavily the business model of naphtha crackers elsewhere in the world. And this is indeed probably one overlooked factor that has caused a strong reduction in petrochemical activity in Europe, alongside others, not least the energy crisis due to Russia's invasion of Ukraine. Now let's indeed have a look at the electrification topic, starting a bit more broadly and then focusing on the chemical industry. Electrification in most cases is the main solution for reducing emissions and can also help addressing energy security. Electricity is today often more expensive than fossil fuels per unit of energy, but electrification options are generally more efficient than conventional fuel-based technologies, and in some cases, they're already cheaper to operate. An important indicator for the competitiveness of electrification solutions can be the ratio between electricity and natural gas prices. We currently see countries having very different price ratios, and these differences are driven by historical choices in energy system design, as well as energy taxation and the availability of natural resources. They differ not only between countries, but also within them, as subsidies, taxes, and grid connection fees can vary substantially between industrial and household consumers. Averaging across these users, countries with lower price ratios typically see higher rates of electrification and per capita energy demand. There is no single energy price ratio at which electrification technologies become cost competitive. The break-even point depends on end-use application as well as a host of other regional factors. Achieving cost parity alone is insufficient to drive the uptake of electrical technologies. High upfront costs discourage investment in electrification across all sectors. But policies and the economic structure matters too, as we see for Asian countries, Japan and Korea in particular, having higher level of electrification than EU countries, despite a comparable, if not lower, electricity to natural gas ratio. The industrial sector is arguably one of the most difficult sectors to electrify. This is because energy-intensive industries, including chemicals, need high temperature heat. Light industries have lower temperature requirements, making heat pumps an attractive solution as they're far more efficient than conventional boilers. As discussed before, upfront costs and electricity prices can still represent the barriers to adoptions also for heat pumps. Other technologies like electric boilers, resistance heating, and arc furnaces are already are needed to extend electrification to higher temperatures. However, these technologies do not offer the same efficiency and advantages as heat pumps, and therefore are generally not competitive with gas today for baseload heat. However, because electric boilers have lower upfront costs, some hybrid configurations which exploit off-peak electricity prices could be competitive, for instance, by coupling with flexible gas boilers or thermal storage. Industrial consumers would benefit from tariff structures which pass through low prices from day-ahead or intraday markets to flexible power consumers, and also lower grid fees for flexible users, which are being implemented in some European countries, could help reward flexibility to make some modes of electrification more competitive. We've seen that that's relatively easier to electrify light industries, and indeed we see that globally the electrification rate has increased in the past 20 years in these industries. Countries in Asia and China in particular have driven these global increases. Progress in the EU, on the other hand, has stalled, creating a potential sweet spot to begin addressing electrification efforts. The picture is different when looking at the chemical sector, where the electricity share in total demand has been broadly constant globally for the last 20 years, even when excluding feedstock, as in the case of the right-hand chart. The difference between countries can be explained by energy availability and costs. For instance, the share of the US has decreased as cheap gas has become more and more available in the last 20 years. But also by product specialization. The chemical industry is very broad, and lots of different industrial processes are involved depending on products and supply chain segment. Acknowledging these nuances, we still observe that the electrification share in the European Union is still higher than in China and than the global average when it comes to the chemical sector. But then, how to decarbonize the chemical sector? The chemical sector accounts for about 16% of global industrial emissions. Only the iron and steel sector and the cement sector emit more than chemicals. We estimate that around 2/3 of those emissions come from production of what we call primary chemicals, namely olefins, ammonia, and methanol. They require high temperatures, and in some cases produce also process emissions, meaning CO2 is a direct product of the industrial process and not coming only from combustion to provide heat. And for these reasons, electrification is only one of the possible solutions that could contribute to delivering emissions reduction in production of primary chemicals, as you can see on the right-hand chart. Other solutions are reuse and recycling, of course, labeled as avoided demand in the chart, energy efficiency, but also other deep decarbonization technologies, such as carbon capture and storage and hydrogen. In the agency, we do quite some work in looking at the development of these technologies that can contribute to emission reductions, both in terms of technology readiness, as in the left-hand chart, which is taken from our Clean Energy Technology Guides, but also in terms of tracking real projects, as in the right-hand chart. Pure electrical technologies, such as electric steam crackers, are still at a relative low TRL stage compared to other technologies for decarbonizing primary chemicals. And in general, thanks to the fact that ammonia is an inorganic chemical, not requiring carbon atom as a feedstock, it is the chemical product showing more progress in terms of low emission projects. Still, projects already operational that have reached final investment decision only accounts for around 3% of 2024 global production levels for ammonia, a share that increases to almost 8% when considering also all feasibility studies. Much slower is the progress in the project pipeline for methanol and olefins. The only low-emission ethylene plants existing today use bioethanol in a process called ethanol dehydration, and the biggest plant is in Brazil. And there is a planned project in Canada, which is supposed to become the first near-zero emissions steam cracker, but its expected operation date has been delayed. Now it's expected by the end of the 2020s. So at the end of these decades. And then there are a bunch of few other projects included for electrification and included using electric steam cracking that are still at prototype or demonstration phase. So this was the end of my presentation. Thank you very much.
Leonardo, thank you very much for your presentation. Based on the analysis of the various data sets, Leandro has demonstrated that the electrification is one of the key strategies for achieving carbon neutrality in the chemical industry. So let's turn to our second presenter, Ms. Sugang Kim from Next Group. Next Group is Agura's Korean partner think tank. In collaboration with Agora, Next Group recently published a joint report of powering the transformation, strategic electrification, and renewable feedstock pathways for Korea's petrochemical industry, which you can download from the Agora and the Next Group's website. The link will be provided soon. So her presentation will provide us with a great opportunity to examine how much electrification can contribute to decarbonizing Korea's chemical industry. So I'd like to invite Ms. Sugang Kim to the stage. Sugang, floor is yours.
Hello, I'm Sugang Kim. I will switch to my slide. Okay, I think you can all see my screen. Yeah, as Kwang introduced, today I'll be presenting on a personal publication with Agora that was released yesterday. It's titled Powering the Transformation, Electrification, and Renewable Feedstock Pathways for Korea's Petrochemical Industry. Next Group is a climate policy think tank working toward a net zero transition in Asia. We conduct research and propose energy and climate policy options to reach carbon neutrality. I'm a researcher on the industry decarbonization team, and I currently focus on the petrochemical, battery, AI, and semiconductor sectors. Here's the agenda for today. First, I'll briefly walk through the landscape of Korea's petrochemical industry. Then I'll introduce the electrification and renewable feedstock production technologies we analyzed and look at the economics of each. Finally, I'll turn to the roadmap for these technologies in Korea, along with the policy proposals that can make it happen. Korea is a manufacturing powerhouse with a globally significant petrochemical sector. After the United States, China, and the Middle East, Korea is the world's first largest producer of base chemicals like ethylene, with an annual ethylene production capacity of 12.8 million tons. Because the domestic market is relatively small, Korea exports more than half of its petrochemical products, reaching 37.8 billion euros in exports as of 2025. The industry has long been a major pillar of the national economy. If you look at the map of Korea below, you can see where the petrochemical complexes sit. The three major complexes are located on the west, south, and east coast, and each one drives the economy of its region. But Korea's petrochemical industry is now facing structural challenges. Korea's industry has focused on the upstream part, making base chemicals. As newer players like China and the Middle East came into the market, the world ended up with too much supply of base chemicals. The oversupply has lasted, and the industry has been in a long slump. Utilization rates have dropped sharply, and last September, the government went so far as to recommend restructuring about 1/3 of current capacity. On top of that, pressure to decarbonize the refining and petrochemical sectors is expected to grow. So the industry has to prepare for a long-term transformation of its entire business. So if Korea wants to turn around this weak performance and win back its global competitiveness, it needs to become a leader in decarbonization. There are other strategies, of course, expanding it into chemical related areas like the battery or building out higher value product lines. But the industry has already been trying this on its own, and we believe decarbonization and diversification have to move forward together. With that emissions reduction goal in mind, let me briefly walk through the emissions profile of Korea's petrochemical industry. Today, petrochemicals are Korea's second most carbon intensive industry after steel, emitting 53 million tons of greenhouse gases a year on Scope 1 basis. 70% of that comes from the upstream cracker process, and over 400 petajoules of petroleum products are burned for process heating. That's because petrochemical production begins by cracking naphtha at very high temperatures. To cut its emissions effectively, Korea's petrochemical industry has to pull all three of the levers you see here. That's because in the chemical industry, there's no silver bullet right now, and a mix of strategies must work together. First, why do restructuring and capacity reduction matter? If companies hold on to their plans simply because they don't want to give up the remaining value in those assets, the payoff from converting facilities for decarbonization falls away. So, producing the same volume from fewer plants at higher utilization is far more efficient than repeatedly shutting plants down and starting them back up with excess capacity. The second lever is electrification. Electrifying the cracker, which is the single largest source of emissions in the petrochemical process today, and electrifying the steam used across petrochemical operations. And the last lever is switching feedstock to bio-based and recycled materials to ultimately reduce our dependence on fossil fuels. Over its whole life cycle, using petroleum-based feedstock for products like plastics creates enormous carbon emissions. Now, let me walk through each of these decarbonization strategies in detail. Let's start with cracking, the single largest source of energy use and emissions in a petrochemical complex. Cracking needs very high heat, and two electric pathways can deliver it. The first is electric furnace. Instead of burning fuel, it uses resistive, inductive, or arc heating to reach the temperatures cracking requires, which is about 850 degrees Celsius. And renewable power that cuts emissions by more than 90%. However, replacing a single cracker that makes 1 million tons of ethylene a year takes about 5.4 terawatt hours a year. So these furnaces have to sit where clean power is cheap and reliable. In terms of maturity, the technology is at the demonstration stage, not yet commercial. BASF is probing it at scale in Germany. The second is shockwave heating. Rather than applying heat gradually, it uses supersonic flow instead of a flame to reach a far higher temperatures, well over 1,000 degrees. It is more energy efficient, but it is the last major of these technologies still at an early development stage, and building specialized system takes a big initial investment. Now to steam and heat. Steam makes up about 10% of Scope 1 emissions, and because it is usually supplied through shared cluster infrastructure, a single investment can cut emissions across several producers at once. These technologies are also closer to commercial use than the cracking options. The industrial heat pumps are the most efficient choice. They upgrade waste heat to the temperatures steam systems needed around 160 degrees, and they are well into demonstration and close to commercial readiness. On the other hand, electric boilers reach higher into the 300 degrees range. Electrode boilers pass current straight through pressurized water, reaching up to 99% efficiency, and they can flux their output with the grid. This is the most mature option, essentially ready to deploy. Both are already running in Germany. And as I mentioned on the earlier three levers slide, the reason we need to switch the feedstock itself from a petroleum base into a bio base is that products made from fossil fuels keep emitting carbon all the way through their use and disposal. This graph shows the estimated distribution of life cycle emissions for basic chemicals in Germany. If a petrochemical product is incinerated at the end of its life, the single step accounts for more than 55% of its total life cycle emissions. The picture in Korea is quite similar. That is why we need to move beyond the conventional fossil feedstock route and open up the bio-based feedstock pathways. With biomass, there are two main options. One is to produce bio-oil, which can be fed straight into the existing process. And the other is to open a new route, such as biomethanol, and produce base chemicals like ethylene and propylene through a new process. Now I'll explain the detail of feedstock pathways. The first is bio-based feedstock. Thermochemically converted biomass can be co-processed directly in existing crackers, replacing fossil naphtha. Two risks matter here: bio-oil, made by fast pyrolysis of dry UD and agriculture residues, and biocrude, made from wet biomass, which needs no pre-drying and thus high moisture rates. The second one is electro-based methanol. Methanol is converted straight to ethylene and propylene through the methanol to olefin process. E-methanol combines renewable hydrogen with captured carbon, while e-biomethanol adds biomass-derived syngas, needs less hydrogen, and is the cheaper near-term option. The third is recycled feedstock. Chemical recycling, mainly pyrolysis, breaks plastic waste back into a naphtha substitute. Alzicam opened Korea's first commercial plant in Dangzin last year, and a newer approach, plasma torch pyrolysis, used an all-electric torch to handle mixed, unsorted plastics, though it is still at an early stage. So now the economics of the transition. Because the electrification ultimately lives or dies on the price of electricity, the most important thing on this slide is how we assume those prices. We use three tariffs. The first is the current tariff for large industrial users. The second is the Renewable Power Purchase Agreement, PPA rate. And the third is the Distributed Energy Special Zone rate. The Distributed Energy Special Zones real cases will start to appear in the second half of this year. So our figure is somewhat optimistic projection. We modeled it about 10% below the current industrial tariff. And with those assumptions, the results split clearly. Electric furnaces add about 10% to ethylene cost, and shockwave heating runs 16 to 20% higher, mostly from capital cost. And heat pumps carry a moderate premium. But electric boilers are the outlier. Even on the best tariff, they cost more than 3 times than the conventional benchmark. So their real value is flexibility running on surplus renewable power. But in practice, when companies weigh an investment, they probably look less at the relative percentage increase and more at the absolute cost, as shown in the table on the right. Seen that way, replacing a cracker is far harder than replacing steam equipment. This is the economics of the renewable feedstock. The chart on the left breaks down the levelized production cost of 4 feedstock pathways, and the one on the right compares the cost of making ethylene through each process. For the bio-based routes, bio-oil and bio-crude, feedstock is by far the largest cost component, which keeps their total cost high. It's in the blue section. And the methanol routes are shaped by hydrogen, which is the gray area. E-methanol is the most expensive. Hydrogen alone makes up about more than 80% of its cost. And e-biomethanol is considerably cheaper because it blends biomass-derived syngas with hydrogen and needs far less of it, which makes it the more resilient near-term option. So at this stage in Korea, both hydrogen and the renewable electricity are too expensive. So compared with a conventional cracker, e-biomethanol and e-methanol come out much higher in cost. And that gap is wider for us, Korea, than in Germany, because Korea's hydrogen and renewable power are more expensive to begin with. Here is the phased roadmap. From now to 2035 is the pilot and first commercial phase. Electric furnaces start with first demonstration, and heat pumps and electric boilers go into selected sites. From 2035 to 2045 is scale-up phase. Furnaces will expand to multiple cracking units, and renewable feedstock crackers move from pilot to commercial stage. And steam electrification reaches the full deployment. And lastly, by 2050, this becomes the standard utility setup, bringing the sector close to net zero. This table summarizes selected policy instruments currently being implemented in major economies. These are the policies supporting petrochemical decarbonization across the value chain. Upstream, covering energy and feedstock access. Midstream, covering production processes like carbon pricing, financing, and industrial standards. And lastly, downstream, covering product regulation. So for the petrochemical industry to transform, we need the policy design that spans the entire value chain. Finally, the policy recommendations. Korea already has the foundations, the emissions trading system, the distributed energy special zone SIN, and the petrochemical support package. These 5 moves close the remaining gaps. First, set a national transition roadmap with phased deployment targets. A second, expand renewable electricity and the grid, since a single electric furnace needs about 5.2 terawatt hours a year. Third, de-risk first mover investment with tools like carbon contracts for difference. Fourth, build renewable feedstock supply chains, securing biomass, waste plastics, and carbon uptake. And last, reform the ESG access and tariffs because affordable clean power is the decisive variable. This is a 2035 blueprint for the Yasu petrochemical complex drawn from a report I published this April. For anyone who wants a more concrete case study, I'd recommend taking a look at that report where we lay out detailed proposals for introducing electric furnaces and heat pumps. And if you visit the Next Grid website, you'll find our other petrochemical reports available in English. And of course, agro-industry has its own research reports on the chemical industry. So thank you. This is the end of my presentation. And if you have some questions, please type into the Zoom Q&A section. Thank you.
Thank you, Sugan, for your presentation. I think I would take over from here. And maybe this is now our time to also get into the panel discussion. I see some of the questions are coming. So in case if you want to type in your answers in the Q&A section, you can do that. But maybe we can also take them at the end of the panel discussion as well. So maybe I would just start. We just heard like 2 excellent presentations, one setting the context of global petrochemical sector, how is that evolving, which countries are key and important for us, and where the challenges are and the opportunities are, and then the South Korea. Maybe I would now invite our panelist. We have a new face joining, Paul Munich. And I would ask Paul to come on the stage of our online stage. And the next is Leonardo, if you can also turn on your camera. And Sugan, if you can also stay in with us and keep your camera on. Yes, thank you. Thank you all for, first of all, being part of this panel. I think here what we heard, we have like a lot of challenges in the market, and I hear like quite a dual challenges which the petrochemical industry is facing. One is like, we want to electrify, we want to be competitive, and at the same time also, how can we look at like emission reduction, with the electrification becoming one of the key part of the solution, but the pace, scale, pathways, deployment differs quite a lot from region to region, country to country. And maybe with that, as we already heard from Korea, how the pathway looks like for them, maybe I would turn towards you, Paul, to start with and understand how does this being seen in the European market, in Germany particularly, when we see they are in the forefront of the electrification of their industries. And we saw from the Sugan's presentation some of the pilot projects which are being also undertaken here. So how do you see these opportunities and challenges in our context of Europe and Germany particularly? Do you see it's kind of similar, or do you see a different pathway is emerging for us here?
Yes, first of all, thank you very much for the very insightful presentations from both of you, Leonardo and Sugang. I think interesting is that Germany and Korea, they share quite a few aspects in like their structural dependence on fossil fuel imports, but also in their very high share of exports of chemical products. And I mean, now we're facing this global issue that Leonardo also alluded to of global overcapacities of chemicals production. And Korea's response is this like more structural consolidation kind of reorganization. So I just get the mission that sound is not very good. Should I switch?
Yeah, it's little electric, maybe.
Okay, maybe I will switch to my laptop audio. Can you hear me?
Yeah, this is good. I can hear you well.
Perfect. Then I'll keep it like that. So Korea's response to this overcapacity is like this more structural, organized consolidation of existing plants, which I think is quite interesting. And I think in the context of this strategic response to this global challenge, it does really make sense to also prepare for the remaining parts of the chemical industry, for these steam crackers, to also go electric. But of course, they also need to find a business case for that. Now, turning more towards Germany and Europe, I mean, we do face a very similar pressure. And in Europe, electrification is increasingly discussed as a key strategy for improving, on the one side, strategic autonomy, but also the competitiveness on the long term. And in Germany, interestingly, the response goes into a little bit different direction of electrification strategy. So in Germany, the integration of renewable electricity and electrification of the steam supply is more prioritized over the electrification of the cracking facilities. So BASF, for instance, has recently realized this e-steam cracker. I think it was it was finalized, I think 2 or 3 years ago. And it is working as a pilot project. However, the further deployment of e-steam crackers is currently not really considered economically viable under the current market conditions. For heat pumps and for e-boilers, the market dynamic is a little bit more promising in Germany. Especially large-scale heat pumps on one side experience an upswing currently. BASF is currently building in its main plant in Ludwigshafen the largest industrial heat pump globally. And also Covestro, as another example, has recently implemented a vapor compression system, which is very much similar to how a heat pump works to save emissions and energy. I think they just deployed or put that into operation, I think last month. So it is also seen as an opportunity to save emission and also cost in the supply of steam, where we do have a quite significant demand. E-boilers are, in my perspective, even more promising at the moment because also of the energy market environment in Germany. So renewable energies in Germany make up to, I think, close to 60% currently in the power supply. And that also results in a higher volatility on the power prices. So we have some hours where electricity is really cheap and also competitive with fossil gas. And an increasing number of chemical companies, I hear that from many different chemical production sites, they are using their backup capacity. Like previously they had like 2 gas boilers, and now they're electrifying one of these boilers to be able to optimize on the energy market. So whenever it is cheaper to produce with electricity, they are doing that. And I think that is very interesting, because that happens already today just due to market incentives, which could, by the way, still be improved. And it does not necessarily require public subsidies. So this is just a market dynamic where renewable electricity can really show its competitive advantage. And I think this example shows very well that electrification of industry and flexibilization can really go hand in hand with the deployment of renewable electricity. Yeah.
Thank you, Paul. I think that's a very interesting point, and particularly your observation that electrification is becoming much competitive issue than just being a decarbonization issue, and which we already see, like the technologies are available, we have the technologies, but when it comes to the implementation and deployment, most of them are facing some challenges. And even your point towards that, highlighting especially the market dynamics, the way things are moving. These are like self-driven. A lot of them are like self-driven engagements on technology deployment. But I still have like one quick follow-up on this one is when you have some of these low-hanging fruits, which seems like much easy to take up, where do you see the policies are playing the role in pushing them further and accelerating the decarbonization in the petrochemical? Do you see the role of the policymakers also coming in here?
Yes, so I would divide that question into 2 elements. Looking at the flexible electric boilers for the start, I mean, we're really having a paradigm shift. In the past, our power system was operated with the aim to have a very efficient system for the use of coal power plants and for nuclear power plants. And now we're moving into a world where everything is a little bit more dynamic. And the incentives in our market development, like in terms of regional incentives to consume electricity where it is produced, but also with regards to the grid congestion, that needs to be taken into account. And right now, industry in Germany is incentivized to have more of a constant electricity demand in terms of their grid fees. So if that is reformed, I think that could even further accelerate the deployment of flexible electrification of the energy supply of chemical industry. Looking at heat pumps, the challenge is at a different point. So what we already see today is that on the operating cost side, heat pumps can save electricity. We've recently published a study where we focused more on SMEs, but there we come to the conclusion that like in the temperature range up to 200 degrees Celsius, we can save up to 30-40% of operating costs over the lifetime of these assets. Why are heat pumps still not implemented? The reason for that is the high upfront capital expenditure. Heat pumps are extremely expensive and way more expensive than the conventional system using fossil gas. And I think that is that's the field where the policymakers should come in to like really create planning security so that investment cases can be developed. So even if you have a high upfront investment, if you can have the planning security that the savings can refinance these upfront capital investments, then this becomes viable economically as well.
Thank you, Paul. I think thanks for in fact highlighting the point on heat pump, because this has been one of the questions of debate on like why the heat pump uptake has been so slow. This has been a technology being proven, being used in several other industries, but the overall scale up and the deployment has been relatively very slow. And yes, we still are struggling with the high capital cost of the heat pumps, which is quite interesting. And we still haven't found some better solutions for that somehow. And that brings me to the point which you also highlighted and which also came out from Leonardo's presentation as well, particularly in the theme that is like today the economics of the electrification remains highly sensitive to the grid flexibility, grid availability, the electricity pricing, the access to low carbon power. So I guess that then I might want to turn towards you, Leonardo, to zoom out a little bit and bringing the global perspective here. How do you see, the petrochemical companies are pursuing electrification preliminary, primary because of the climate policy and regulatory pressures? And how do you see that differently happening? Because you also highlighted, the challenges which is being also faced similarly in the other countries as well. Not just from the Korea, we also hear like in Germany, it's kind of like similar challenges. And from your presentation, the North America and China are also the ones who would be almost going into the similar track. So how do you I just packaged it all together, but how do you see these reflections on like from the global perspective from your side?
Sure. Thank you very much for the question. And yeah, I mean, to start with, I agree with many points that Paul made before. And looking at more the global, I mean, if we're starting with the similarity with Korea and Germany and the European situation, I mean, taking more a global perspective, I mean, and to add the point on the electrification of the industry is that in such a oversupplied market conditions where margins are very low because of the oversupply, I mean, trying to invest in new plants and in new technologies is even harder. And even for instance, for electric crackers, where it's true, like the capital cost of an electric cracker is not probably higher than a normal cracker, and it can bring some efficiency improvements. And still, if the electricity price is low enough, you could even think of lowering the operating cost. But the thing is, investing in such a new technologies in a brownfield is really hard. Like there's a lot to change, and while investing in a greenfield facility in such an oversupplied market is hard to find a business case for that. So I guess that's a bit the global picture that is valid for Germany, for Korea, for all places basically. And then and I mean in for these countries like Germany, Korea, I mean Asia and Europe in particular, not having, I mean, because like the competitiveness of the industry today, the main driver is the access to cheap feedstock, basically, and not having this comparative advantage when compared Europe to the Middle East or the United States. It's yeah, I mean, it's difficult to overcome, and even more difficult in such an oversupplied market, I would say.
Mm-hmm. Thanks. I think that provides quite of a reality check for us, especially highlighting on the, overcapacity issues and oversupply issues. I guess that has been kind of like consistent that I hear in the other sectors as well. And it's really hard to overcome some of these persisting issues, especially when we have to bring like a strategic business competitiveness in the emerging markets and also at the same time the economic growth. So it becomes really challenging to talk about in these sensitive markets particularly. Maybe I would like to nudge you a little bit more on, you spoke about a little bit about these issues in the different market, but there was also a question in the chat box for us. Maybe I would like to bring that also here, like especially, when we are talking about these restructuring, which is happening across different countries. And do you think we can, during that provides like a sort of like an opportunity for us to accelerate the electrification and also to overcome some of these challenges of the oversupply and overcapacities, and we could overcome some of these economic pressure, or would this be adding more to the economic pressure? How do you see the restructuring which is happening across different continents and geographies be playing the role in the decarbonization?
Yeah, thank you. That's a good question, and I would like to echo again, like Paul's point before, on these this orderly consolidation happening in Korea, which is very interesting and quite different from what's happening in Europe, which is a bit more like a disorderly shutdowns of plants here and there. So like I think having a strategy for bringing together the industry, the companies working in the industry, and finding a way together in a jurisdiction to find a way to consolidate the markets, find a way to to allow companies to have higher margins as capacity reduces. It's in an orderly way. I think it's a very interesting. Having more strategy is very important. And then yes, this consolidation can help companies increasing the operation rates, having a healthier balance sheet that could allow at some point some more investments, definitely. But again, I'm picking up again the point I was making before. Adding new capacity, new greenfields in such an oversupplied market can still be an issue. But definitely consolidation can bring a more healthier business environment that can at some point allow more investments also in cleaner solutions.
Thank you, Leonardo. I think you made a very valid point on what can the different places can play their role, and how especially the greenfield projects and lowering the operating cost would be a very important point. And I think that was also kind of like a highlight that I take away from your presentation as well. It was quite insightful to hear about the electricity pricing, how that would be playing a major role. And while we were doing the analysis for the Korea, I think that was also kind of quite clear that different economics, which even Sugan has presented, how the economics of different technology is largely being played by, or largely being driven by the electricity pricing, and that is making it really hard to invest in some of these technologies in South Korea. And that brings me to zoom in and move towards you, Sugan, and see further, like, what's your reflection on restructuring? Because we have been hearing at the global level this is happening, and this is also happening in South Korea. We know that the Korea's petrochemical is currently undergoing a significant restructuring, while the government is also preparing the new support measures for industrial transformation. How do you see this as the priority actions that government and the industry should take in the next 5 years? And which I think this is a unique window of opportunity that we can rethink of the sectors can evolve. So how is this being looked in South Korea by industry and the government people?
Okay, let me start with the short answer. I see restructuring and new investments for decarbonization as very
Sorry to interrupt. Can you hold your mic a bit more closer? Yeah.
Okay. I think restructuring and new investments for decarbonization is quite a separate steps. It's not really that restructuring is holding back new investment. The key variable is the communication and the will between the government and the companies, I think. Restructuring happened because the government pushed for it and companies began announcing cuts late last year. But in the end, those were corporate decisions. However, new investments for business transformation is quite different. The companies don't have the will to do it on their own, so the government needs to support the start. And building that plan is taking a quite long time because just 2 years ago, the government and the industry were in very different places. So Korea's petrochemical industry has struggled since 2021, so it's now in about its 5th year of long downturn. And the companies kept saying they were already shrinking their business and has no room to invest in new technologies. So they wanted was immediate tax cuts and electricity price cuts, but the Korean government doesn't give that kind of unconditional support to large corporations, so it doesn't accept those demands. However, Next Group made a proposal to bridge this gap. A conditional government support aimed at a transition toward clean chemical industry. Well, Korea's petrochemical complexes sit on the coast far from the capital, Seoul, and they have long carried their regional economies. Now, those regional economies are at risk of collapse. To prevent that, the government should support new investments in these areas. Transition to clean chemicals fits their goals because it means regaining global competitiveness while building new technologies. And if local voters also speak up for a clean transition and give the government a clear mandate, I think the government can move faster on the early stage investment. So there are some few cases where petrochemical companies invested in alternative feedstock like bio-naphtha or plastic pyrolysis oil with no government support at all. But even those run into serious losses and become hard to operate unless the government puts the system in the place. Also, projects like CCUS cluster can only move forward if the government first lays the pipeline and infrastructures in the region. So to sum up again, over the past 5 years, new investment into new business has almost disappeared in Korea's petrochemical industry. So whatever direction the government sets for new investment, the companies will follow. And I think this pattern will likely play out in a similar way for other countries in the global petrochemical market. And if I can add some explanations about the policies in Korea right now. So far, policies on the clean transition of the petrochemical industry have named a few technologies or laid out some R&D plans, but they've never announced a concrete roadmap or a scale of investment. So that is the kind of policy we are hoping for. And a green transformation policy is due to be announced in the second half of this year. So we are hopeful it will include the detailed support for the petrochemical industry.
That's quite interesting to hear. Thanks for those updates on the policies. And hearing your view on the restructuring, it sounds very positive, and it's quite nice to hear that you see this as, and the government and the industries are also looking forward to that and would be using this as a unique opportunity for the major investment towards the decarbonization. Maybe I would like to go back to you, Paul, and see what is this as a restructuring being taken in the Germany level? Are you seeing the similar sort of like the perspective, or are you hearing a different story here?
That is a very good question. I mean, as I already elaborated on, the challenges are very similar.
Yeah.
The responses currently are a little bit different. We, as Leonardo also pointed out, the reducing of production of chemicals in Europe and in Germany in particular is currently not organized in a way. Like, it's more like companies are trying to find their best individual position on the market, which is natural. What I find interesting is that the labor union, IGBCE, recently started advocating for a similar approach, an organized consolidation, which would then be similar to what has happened already in the past with the phase down of coal in power production in Germany. I think this is a very interesting approach to do, because it would also allow to really more actively steer the transformation. Because maybe another story which I find quite interesting. In Germany, we have different clusters of chemical production, and the Eastern German chemical cluster is really much relying on a steam cracker by the company Dow. And last year, Dow has published their plans to shut down this plant, I think by next year, which in turn really jeopardizes many of the downstream production here in Eastern Germany. And so far, there is no structural response, neither by the local nor by the federal government, nor by chemical companies. It's more like individual companies trying to find how to still source their resources. And interestingly, at the same time, another company, INEOS, is building a large ethane cracker at the coast of Antwerp in Belgium. And it's one of the largest cracker facilities, I believe, globally. And it is not running on oil-based naphtha, but on ethane, which is a co-product from fracking, like natural gas fracking processes in the USA. So it relies, again, on fossil imports. And it also produces ethylene. So we have another player on the market, which, again, puts more capacity on a market which is already oversupplied. So they do that because they think they can be cheaper with this ethane-based production of ethylene than with oil-based production of ethylene. So we will have like again, even more pressure on the existing chemical plants in Europe. And it will be, we will have to see how that impacts potential closures or reduction of production capacities. But this is not managed, and it's a question like, do we want this as like the European Union? Do we want this consolidation in an unmanaged manner, which would jeopardize production sites that already exist, or would we rather move towards new production methods that are maybe putting these landlocked chemical sites more at advantage?
Yeah, thanks, Paul. I think very well put together. I think that's a very valid point, and that also helps me in segueing towards my last question, and that perfectly fits, like you highlighted, and all the speakers actually highlighted some of the common themes which has emerged as the many challenges on electricity pricing, infrastructure, investment, risk, technology deployment, feedstock supply chain. And this is not just unique to just Korea, but this is something which we are seeing across the whole of the globe. And this brings me to the question, and what you also raised, Paul, on the downside and on the demand side. So looking at from the international partnership point of view, that now that we are speaking and goes beyond the regional and the country boundaries, if we have to expand ourselves, and so what kind of the partnerships can these help, and what kind of cooperations can this help in deployment of overcoming some of these common issues, whether it's the lead market on the demand side policies, the standards and the certification, the green methanol and the green naphtha value chain, as you also highlighted that. So what kind of joint innovations that could happen? Possibly, I can maybe start with Leonardo, with you, and then I can move to Paul and then Sugan.
Sure. So, I mean, on lead markets, yeah, definitely. I mean, lead markets are an important option for triggering some investments in these decarbonized technologies and these decarbonized paths. As we've seen in this context of oversupply, where alternative, decarbonization technologies in most cases still present, at least in the industrial sector and the chemical sector, still present a price premium. Creating parallel markets where you can sell greener products to customers that are willing to pay a bit more for these cleaner products is very, very important. How to do that? There are different ways, like but there are different ways, but start with defining what is a green or low emissions molecule that you can sell in the market is probably the first step you need to do. Defining standards, defining definitions of what a low emissions molecule is the first step to start with for creating these parallel and lead markets. The chemical supply chain is, the chemical industry in this respect is a bit behind other heavy industries. There are some standards and definitions a bit more advanced, for instance, for steel, as well as for cement. halting the chemical industry is also the complexity of the supply chain, because there are many different products. It's not just steel. There are many different products, and going and regulating each product, it can be a bit complex, and the risk of over-regulation and a risk of creating damage instead of simply creating these new markets that can be useful. I mean, I don't have a clear solution for that, but definitely, I mean, lead markets are very important, but the complexity of the chemical supply chain is something to tackle when defining these lead markets.
Yeah. No, thanks, Yad. I think you already highlighted a very important point of like defining some of the standards together and creating the market and then finding the parallel markets. I guess those are really important, and we don't have to find the solution. We just have to like find a pathway towards the solution. And maybe now I move to Paul. How do you reflect on this? What's your brief reflection on it?
Yeah. Thanks for the question. I mean, as also highlighted in next group study, the emission reduction in the chemical industry does entail additional cost. Electrification is like the first step, but if we go to the next step, which would also include renewable feedstocks, without like producing chemicals without fossil resources, that will on the long term increase the cost of chemicals. And at the same time, I do think that is a way we can go, and also where we can go competitively. But the requirement for that is that we need to be able to valorize this additional characteristic that chemicals are then produced in a more strategic, autonomous way, that they are produced with lower emissions, with less fossil input. So we need to be able to differentiate the markets there. And then come into play all these elements that Leonardo mentioned, like labels, standards, creating like separate markets for these new kinds of products. And the chemical industry at the same time is an extremely global industry. A movement just by Germany or just by Korea will not be successful. So there is a huge, like, I wouldn't just say chance, but there's like this requirement that countries who want to go this way, who want to push for renewable chemicals on the long term, they have to team up and build these new markets so that they become of a critical size. And only that will like make this transition successful in the long term.
No, yeah, totally right. I think looking at all the challenges, every country is facing a similar issues, and just one person or just one country can't solve all of that. There has to be more of the international collaboration. There has to be more of the partnerships and cooperations that has to come together, and finding the solutions which are more long term, as you also highlighted, not just looking at the short term solutions, but more of the long term solutions to team up and provide the required ways to accelerate the transition. So Sugun, are you like, do you always like, if you have more to add on to it, but also are you hearing some similar sort of like cooperation, like EU-Korea cooperation, or some similar sort of like collaborations at the international level that Korea is looking at? And how do you see the perspectives on the international collaboration?
Well, it's quite sad that I cannot provide some exact examples on this question, but I kind of agree with Paul, because when it comes to regulations for clean chemical productions, realistically, the only thing we can point to right now is CBAM, and even that doesn't yet have a firm standards or a fixed timeline. So I think the most effective starting point would be on the consuming side, the consuming country. If they set clear standards for clean chemical products first, and price them accordingly, the manufacturing countries will follow, I think. So sadly, we've already seen how hard it is to build global standards as with the plastics treaty. So I think it has to start with the countries at the downstream end of the value chain.
Yeah, that's right. Thanks. Thank you. Well, just looking at the time, I think we had a quite of an enriched discussion and also bringing all of those points. Thank you. I would like to now thank you, all of you, and for sharing your insight and perspective today. Just looking also in some of the questions, I see some of the questions have already been answered at the live, but I would also encourage the participants in case if you have more questions to also put in your question and there. And even if you have some questions maybe later, you can always reach out to us through our email or with the publications that is already being posted in the chat. I think the discussion has already highlighted both the scale of challenges and opportunities ahead. While the pathways may differ across the regions, but the competitiveness, the different kind of a market that needs to be created, the challenges on the the economics as well as the oversupply issues, those clearly highlight that we need to think together and we need to advance together, trying to find out some of these pathways, even if we can't find all the solutions together, and no single technologies like we see, or the technologies are being deployed, but a lot of them are also facing issues with the deployment and with the operationalizing them. So at the country level, we might not be able to just deliver the transition alone. Collaboration across like industries, across value chain, and across the region would be much more essential. And with that, I hope that today's exchange could contribute to strengthening some of these dialogues and cooperations between not just Korea and Europe, but wide globally to bring more competitiveness and low carbon chemical sector. And with that, I thank all my panelists for their insightful and very experienced knowledge in the chemical sector, sharing with us and giving us the perspective on the chemical sector. Thank you so much. And with this, I see if there are any more questions. Maybe I can pick one question which is kind of interesting and might be we can all see to answer that together. How do you see the alternative feedstock interacting with electrification as complementary pathway or competing one? It's Sugan or Paul. Any one of you want to go ahead and answer that?
I can also jump in if needed. Yeah, I mean, they're definitely complementary. I mean, you can have an electric steam cracker running on fossil feedstock or a conventional steam cracker running on alternative feedstock and recycle the byproducts and burn them. So they're definitely complementary. The economics are different. In particular, when looking at alternative feedstock, depends on what kind of alternative feedstock we're talking about, as Sugan was showing also in her presentation. There are some plants already existing, like in Brazil, there's a big one. There's a slightly different technologies that produce ethylene using bioethanol. I mean, and other alternatives for producing like this bio-naphtha or e-naphtha. But I mean, yeah, the question is on the economics, in particularly on the electric alternative feedstock, like the e-naphtha. I think the economics is very hard, is very complex. On the bio side, I mean, there are questions about how scalable they are, how actually sustainable sometimes they are, how available at all as well. But probably the economics are a bit a bit better than, I mean, definitely better than the naphtha solution.
Yeah. Thanks, Leonardo, for answering that question. Paul, do you have any further points to add on that?
Yes, I can add to that. I mean, if you just look at efficiencies and costs, then we would probably see more of the methanol-based production of ethylene in the future than the steam cracker-based production. That is, however, just one perspective on the transformation. The transformation to renewable energies is not an economic one only. It is also a social and it's also a social one. So taking into account like existing sites and existing structures, I think it always needs to be something where like a process where we combine new innovative processes which are maybe more disruptive and also preserving existing sites just for the sake of like the history and the social aspects of the transformation. And I think these two can go hand in hand. And I think electrification on that end of, for example, steam crackers, I think it would be a great progress if in a few years' time we would see some large-scale steam crackers electrified, even though they run still on fossil fuels. I think this is just like we're going one step at a time. We have to make sure that we do not lock in one technology entirely. I think right now, looking at the investments taking place, I don't see the risk that electrifying all steam crackers on the planet, I don't see that happening. So I think the risk of a fossil lock-in in that regard is relatively slow. Relatively small, yeah.
Yeah. Thanks, Paul. Sagan, do you have any points to add in there?
Yeah, I already answered to the gym Q&A section. But I think, yeah, for Korea, the landscape is totally different from Europe and Germany because we have to rely on import about biomass and green hydrogen, I think. So it's really hard for us to scale up the alternative feedstocks in the near future. So we have to like try both strategies like electrification and the alternative feedstocks at the same time, because if we focused on only one of those strategies, there will be some problems if we fail to scale up that strategies. So for now, it would be wise to try all the options that we can try right now. So yeah, I think it is a complementary pathways rather than a competing pathways right now.
Thanks, Sagan, for highlighting that. I think we don't have any more questions. With this, I thank all of you once again. Thanks for joining the panel discussion, and thanks for also presenting such insightful presentations. And it was quite interesting to hear some of these messages, which is coming quite clearly, the different challenges which still there's, but we also have the solutions. It's just we have to figure out how do we collaborate together, how do we find the right pathways and right unique windows of opportunity, which is also seems to be coming in, to find the solutions together and strengthen the case for deeper engagements on the chemical decarbonization. So building these alliances will definitely be critical for accelerating the transition and creating a competitive market. And also what the point which Kwang Hee in the beginning highlighted about the oil crisis and the way with things moving right now in the energy sector, I think that it's really important. I think we found some of the very niche solutions and also very specific pathways that we can definitely look forward to. And I really thank my panelists for bringing all those insightfuls and the expert inputs.